Let's combine algebraic expressions under addition and subtraction processes. When we try to add or subtract polynomials or algebraic expressions, there's one thing that we always need to consider: similarity or likeness of terms. Imagine this. In a fruit stand, you always see bunch of fruits separated by their type. You have see mangoes, oranges, watermelons, apples, etc., etc. But you could not see a fruit stand wherein all of those fruits are mixed in their stand, unless you're having a shake or a halo-halo. But what my point here is this: when you talk about addition or subtraction of polynomials, you always consider which group can be combined and which group cannot be. So in this case, we need to identify first likeness of terms before, sorry, my bad, likeness of terms before we could add or subtract polynomials. And if we do, always consider that there are important procedures for us to decide what would be the result. We have here one, two, three, four items, and we are going to talk about them one by one. When you talk about likeness of terms, you only need to look at the literal coefficients. So if you have 2x and 2y, even if they have the same numerical coefficient, you have here the literal coefficient of x and y, and if we're going to add them, we cannot combine them into one. So should be our final answer. Aside from that, if you also talk about x and x squared, even if they have the same variable, they are not of the same literal coefficients. Why? Please be reminded of that x squared is actually x times x. There are two x's there. So the two x's is not similar to one x. And is therefore, if we're going to subtract them, we cannot combine them and yield only with this result. So again, likeness of terms is very important. For number one, we can see here three different terms with that are considered to be like terms. We have here 5k minus 3k and plus 7k. Why? Because when you look at their literal coefficients, both all of the expressions or of all of these three expressions here or terms have the um, literal coefficient of k. And we have here the last term as a constant. So we cannot combine this to any of the three. Only these three can be combined. And how do we combine it? When we answer addition or subtraction of polynomials, we only copy the similar literal coefficient and proceed to operate the numerical coefficients. I'm talking about the numerical coefficients of 5, 3, and 7. And how do we operate them? Simply use the operation separating them. 5 minus 3 is positive 2, plus 7, you have positive 9. So the combination for these three different terms is 9k. How about the positive one here, or the plus 1, the last term? Just simply to add here plus 1. We cannot combine them and say, I have here 10k because I added 9 and 1. We cannot do that because 1 here is not with k. They are unlike terms, so the final result is this one. Another thing that you may mistakenly do here is by answering 9k cubed, because you also added the exponents, because you are thinking probably of multiplication law of exponents. By the name itself, it's multiplication law of exponents. That's only possible when you are multiplying polynomials. Just like this one, 5k times 3k. So you're multiplying them. Multiply 5 times 3, you will get 15. K times K, and because of the same basis, you will have K 1 plus 1, which will result later on to 15K squared. The addition of exponent is only possible if the terms are being multiplied. So you cannot answer like this because in the first place, what is the given? The given is only addition and subtraction of the terms. So this is now the final answer. I'm just emphasizing that one. Let's proceed to number two. In number two, you might notice here a grouping symbol. Do not assume that you could just simply proceed with 4 minus 4 and say this will become 0, sir, because that's 4 minus 4. Do not do that because there is a grouping symbol here. And when you talk about a grouping symbol with a coefficient outside, you're going to use here the distributive property. And distributive property tells us to multiply this coefficient outside or expression, probably soon outside, to all the terms inside. And that would actually be multiplication. So 2 times x, you have 2x plus 2 times 4, which is 8. Also, do not assume to include this one because the remaining terms here are not part of the grouping symbol. So simply write them as they are. So this is the first step after you have applied the distributive property properly. Do not say only 2x and you have here 4 because the 4, the coefficient 4 is part of the grouping symbol that should undergo the same distributive property. So it's correct to assume it's 8. With this, we have here similar terms, this one and this expression. So since they have the same variable x, their result should also carry x. And then proceed with the operation using the numerical coefficients. Take note that if we have a variable alone, there is a 1 coefficient there. In short, 2 minus 1 is you have 1. 1 what? 1 x. As for the constants, you have here 8, you have minus 4, you will have plus 4. Do not assume that it's correct to simply place it like that because they are of different operations now, just like what happened in number one. The plus 1 will just remain as plus 1. So if you have 8 minus 4 is positive 4, the positive will become an operation plus, and you have here 4. This is the product of the second step. This is not yet the final answer because we still need to simplify this. I'm talking about the one coefficient. You may not need to write that, and your answer here is x plus 4. This is the product, I mean the result, when you simplify number two, undergoing distributive property and the correct processes of addition and subtraction of polynomials. Let us proceed to number three, and this is where it gets tricky now. Take note that there are still grouping symbols here, but instead of a numerical coefficient outside, we could see here signs. Here. There are important rules when removing grouping symbols preceded by a sign. Do not assume that you can do this. I could answer, sir, m squared plus 3 minus 2m squared plus 4m, and you have here minus 5m minus 2. This is my next processor because I just simply remove grouping symbols at once. Some may be correct, but even if one is wrong, everything will be wrong. What is my point here? When you have a grouping symbol and preceded by a sign, there is a specific concept to be done. Let's look at the first grouping symbol. Of course, m squared is not part of the grouping symbol, so let's just simply write m squared here as we go through the process. The first grouping symbol is preceded by a plus sign. The rule there is that whenever you have a sign, a positive sign right before the grouping symbol, you can just simply remove it. The way you're thinking earlier, that's partially correct. You can remove the grouping symbol at ease, no problem. So I'm removing the grouping symbol until here. I have 3 minus 2m squared and then plus 4m. That is the correct process when you have a grouping symbol preceded by a plus sign. So it's almost correct to what we did earlier. However, here's the catch. If the grouping symbol is before the if the sign before the grouping symbol is minus or negative, or let's say minus, it it's not safe to automatically remove the grouping symbol. I'm talking here about the property that when you try to remove a grouping symbol preceded by a minus sign, all the signs inside the grouping symbol, signs of numerical coefficient by the way, will be changed into their opposites. I'm talking about the sign of 5 here in 5m. 5m or 5, the numerical coefficient of 5 in 5m is positive. But once we remove the grouping symbol, since it's preceded by a minus sign, the positive 5m will become minus 5m. So it's just simply as removing, sir? No, no. Here's the other thing. The next expression or term is minus 2. It's minus or negative, minus 2. As I've mentioned before, the operation could actually be its the sign of the numerical coefficient. Okay? The sign here is minus, and it's part of the grouping symbol preceded by a minus sign. Once I remove the grouping symbol, the negative sign will become plus 2. This is the only problem earlier when you remove everything without considering this concept. Why is this so? This actually, with the use of the pattern we did earlier here, just that it's a numerical coefficient. But here we were going to use it in a sign or yes, a sign, a positive or negative sign. We are going to use the distributive property. Let's look at the first grouping symbol preceded by a plus sign, and which I mentioned earlier that all signs will remain the same. The plus 3 is still plus 3, the minus 2 is still minus 2, and the plus 4 is still plus 4. That's the shortcut. But the truth behind is we are actually distributing the sign of plus inside in the process of multiplication. No worries because it's a plus sign. When you have plus time a positive times positive, that's why it's still positive 3. Positive times negative, it's still minus 2, negative 2. Positive times positive, it's still plus 4 or positive 4. That is why, as I mentioned earlier, you can remove the grouping symbol at ease without changing the sign of the terms inside the grouping symbol if it's preceded by a positive sign. But for the second group, which is negative, you are, as I mentioned earlier, the signs were changed from plus 5, it became minus 5, and the minus 2 becomes plus 2. It's actually a product when we multiply the negative sign to all the terms inside. So the negative or the minus sign times positive 5, multiplying two numbers with different signs, you will have negative 5. And negative times negative, you have positive 2 or plus 2. That's the truth behind it. Or basically, if you just would like to refer to the first thing I mentioned earlier, in a grouping symbol, if it's preceded by a plus sign, you may remove it at ease without changing the signs of the terms inside that grouping symbol. However, if there is a grouping symbol and the sign before it is negative, in, interchange all signs into their opposites. So the mention what I mentioned here, the plus 5 becomes minus 5, and the minus 2 becomes plus 2. This is very important because the next step here is just simply combining similar terms. I'm talking about this term here and this one. Do not combine m squared and 4m because then again they have different numerical, literal coefficients rather. So what we could do is to combine first the m squared. Understandably, it has 1 here. So 1 minus 2 is negative 1. Negative 1 what? Negative 1 m squared. For the first terms to be combined. Next, let's try to combine here these two. 4m and 5m has the same literal coefficient. So we can simply copy the m, and 4 minus 5 is minus 1m. So you have minus 1m. And finally, for the constant, we have 3 plus 2. The result here is plus 5. To make this more formal, let's not include 1 as negative 1, and you can just simply have negative m squared minus m plus 5. This was made possible by understanding the concept of signs before grouping symbol. Let's talk about this one here. This is when you do the same things earlier, but let's just copy the first term as it doesn't have a grouping symbol. So negative xy. The next grouping symbol has positive sign or plus sign before it. So the positive x will still be positive x. The negative xy will still be negative xy. The signs are not changed into their opposites. But for the next grouping symbol, since it's preceded by a negative sign, the positive 3 supposedly inside the grouping symbol will become negative 3xy, and then the minus x will become plus x, interchanged into their opposite signs. And then, to be followed with their proper combination, you have negative 1xy, negative 1xy, negative 3xy. You just need to review the operations in integers, negative 1, negative 1, negative 3, a total of negative 5 what? Negative 5 xy. By the way, why do I keep repeat what? Because it's very important. Just like even in your elementary years, part of the problem solving, let's say it's all about apples. The result is 5 apples. If your answer is just 5, your teacher would say, 5 what? 5 sacks of rice, 5,000 pesos, 5 kilometers. What is that 5? 5 apples. That's why the label is very important in your elementary years. Here, labels are still important, but the labels are not considered to be the literal coefficients. So it's negative 5 what? Negative 5 x, y. And then you have here plus x, plus x. Again, there are 1 coefficients there. 1 plus 1, we have positive 2 what? 2x. Can we combine these two? The answer is no, because you have here a variable y for the first term, which could make them unlike terms. And this is now your final answer. So the thing here is this: likeness of terms, very important, and definitely the rules on the grouping symbols preceded by a sign. Please review this as part of your preparation for the next few lessons. See ya.